So this is writing formulas for ionic compounds. Here's a couple rules, and I'll show you how to use it. So if you have an ionic compound, that means you're going to have a cation and an anion. Cations are usually metals. Anions are usually nonmetals. When you combine cations and anions, the ratios have to be right. Cations have lost electrons, anions have gained them. You need a ratio of ions where the total charge is 0. I'll show you how to do that. So total charge must be 0. However many positives you have has to add up to how many negatives you have. What you're going to do, you're going to crisscross the charges and reduce. Okay, so you look at the charges. I'd like to add something to that. I'm going to add its absolute value. Okay? You're going to crisscross the absolute value of the charges and reduce. So if one ion is +2, you're thinking about the 2. If another ion is -3, you're thinking about the 3, right? It's the value of the charge. And make sure you use parentheses for polyatomic ions. All right, let's look at some examples. So if you had sodium and oxygen, and you had sodium and oxide ions, and you wanted to find a formula that would work, well, actually, maybe you know how to predict the charge. So you find sodium on the periodic table. You should find it in group 1. You should say, oh, that's going to form a +1 ion. And then oxygen you find in group 16, and in group 16 you wrote the -2, that's or 2-. Either way, it's okay. But we have a 2- ion. Okay, so we know the charges, and this one is pretty simple. You can kind of see that we're going to need 2 of these for one of these. But what I wrote here, and I'm showing you what to do here. Crisscross the charges. These are the charges, and it's the absolute value. This is plus. But that's +1. We don't write it. We just write plus. But that's +1. So that plus, or the 1 rather, is going to become a subscript for oxygen, and this 2 is going to be a subscript for sodium. And so the formula that we would write would be this. We don't need to write the 1. If you wrote it, it just looks weird. Writing a 1 really isn't going to make it wrong. It is a 2-to-1 ratio. But this is the best formula to write for sodium oxide. This subscript tells you how many of each atom you have. So Na2O, 2 sodium ions for every 1 oxide ion. That makes sense based on the charge, because this is +1, so we need 2 +1s for every -2. That one. Next one is calcium and sulfur. So you take a look at calcium, find it on the periodic table. It's element number 20, which is in group 2. Calcium is 2+. Sulfur. Sulfur is right underneath oxygen in group 16, and that's 2-. Okay, this one is, I think, kind of easier. I wrote for you, crisscross the absolute value of the charges and reduce. So we're going to take this 2, put it down here. This 2, put it down here. If we just wrote the numbers, we'd write that, but we can reduce this, and so we do. So our answer actually should be CaS. Now, writing this is not really the end of the world, but this is a better thing to write. So make sure you're in the habit of looking for things that reduce, looking for ratios of ions that reduce. So this is only for when you do. All right, that's that. I got a couple more examples because I mentioned polyatomic ions. Right? Make sure you use parentheses for polyatomic ions, and that's any time you have more than one. So, okay, so we have aluminum and carbonate. For carbonate, you might not have that memorized yet, but you will. CO3 2- is carbonate. It's a very common ion. It's in your houses. You dealt with it in lab. Aluminum. You can find aluminum on your periodic table. It's element 13. And it's in group 13. So you predict 3+. Now for this one, we're going to crisscross, same as we did before. However, you got to be careful because this already has a subscript in the place where we put it last time. So what I'm going to do is I'm going to put parentheses around here. Notice when I put the parentheses, I left the charge outside of the parentheses. But maybe it doesn't matter a whole lot. So now I'm going to crisscross the charges, same as before. The 3 goes outside of the parentheses. The 2 goes for the aluminum. And our final formula that. This formula says we have 2 aluminum ions for every 3 carbonate ions. And that makes sense. 3 times -2 is -6, and 2 times +3 is +6. I could kind of write that out, right? It would be like, there's -2, -2, -2, right? There's 3 of these, right? If I'm just thinking about charges. And over here, there's 2 aluminums, which is +3 and +3, right? But they add up to 0. So that's all we're doing. We're making these ratios so that the total charge is 0, which means we're accounting for all the electrons that should be there. That's aluminum carbonate. And one more example. Nitrate. This is NO3-. Nitrate, that's a very common ion as well. You're going to get to know it, so you can memorize it now. Be careful here, right? There's no number next to this minus, but this is a -1 ion. The 3 is only for the oxygen. 1 nitrogen atom, 3 oxygen atoms, and overall a -1 charge. I'm going to put this with iron 2+. You can find iron on your periodic table. It's element 26. It's in the transition metal section. And iron either forms a +2 or a +3 ion. I picked one for you. Okay, I'll show you later how to find that if you know some other things. But let's make a formula for iron 2 nitrate. So again, we're taking this 1, right? It's not the negative. We're not putting a negative down here. The 1 goes down here. And on the other side of these parentheses, I'm going to put that 2. So this is going to be Fe1 NO3 2. Parentheses for polyatomic ions. That's what I'm talking about.